looking at now is how we can differentiate with negative powers. We have looked at this a little bit before, so we're just essentially going to do some examples together and see what comes of it. Okay, so when we're looking at this, whenever we're trying to differentiate things, please make sure you read very carefully what the question says. This question says differentiate the following with respect to x. Now in this case we only have x's in our function, that's the only pronumeral, but sometimes we actually have different pronumerals and we have to make sure that we differentiate in terms of whichever value is actually given. So when we're differentiating, remember our basic rule from earlier. If we had y equals x to the power of n, to find our derivative, the rule is that we multiply by the power and then we subtract 1 from the power. And we're going to use that regardless of what this power is. Whether the power is negative, positive, a fraction, we apply the same rule. To differentiate, we were given a function in terms of f of x, therefore we need to use the corresponding notation, and our derivative would be of the form f dash of x. So to differentiate, we multiply by the power. So we'll have 6 multiplied by the power, which is negative 3. X to the power of, we subtract 1 from the power, so it will be negative 3 minus 1. Plus, for our second term, we have 3. We multiply by the power, which is negative 1. We subtract 1 from the power, so I'll have negative 1 minus 1. If we simplify this, 6 times negative 3 gives me negative 18. X to the power of negative 3 minus 1 is negative 4. For the second term, 3 times negative 1 is negative 3. X to the power of negative 1 minus 1 is negative 2. Now please be careful when you're doing this. You can, if you would like, skip the first step and go straight to the second. This is a completely acceptable answer. However, you could also express this with positive indices if you would like. 18 remains in the numerator. To make the power of 4 positive, the x part must be moved to the denominator. Again, the 3 remains in the numerator. For the power to become positive, we need to move x to the denominator. We could also give our answer like so. Or, if we chose and we wanted a common denominator of x to the power of 4, negative 18 already has a common denominator. If we're wanting to ensure that our x squared has it, we need to multiply that by x squared top and bottom so that we are able to get a common denominator there of x to the power of 4. Now any of those answers are completely acceptable. You do not need to simplify and go further unless the question specifically asks you to. So all 3 options here are both acceptable ways of leaving your final answer. Okay, for the next question, now we have a fraction here. Later on in the year, we will learn that when we are dividing, we have something called the quotient rule that will help us to work this out. However, we haven't used it yet, and it's actually not necessary, because when we are dividing by a single term like we are here, all we need to do is to take each term in the numerator and divide it by the denominator. So if we're dividing 5x squared minus x cubed, x squared minus x cubed, x squared divided by x cubed is what we're doing. So we're saying 5x squared divided by x cubed. When we're dividing, we subtract the powers, so we get 5x to the power of negative 1. Minus, we do the same thing for the second part, 6x divided by x cubed. We subtract the powers, so we get 6x to the power of negative 2. Now this is not the derivative, this is just us rewriting the function for y. To differentiate, be clear when we're differentiating we must use the correct notation, dy dx, because that matches the y that was given to start with. The derivative I multiply by the power. 5 times negative 1 is negative 5. X to the power of, I subtract 1 from the power, giving me negative 2. I multiply by the power, negative 6 times negative 2 gives me positive 12. And I subtract 1 from the power, x to the power of negative 3. Once again, I can leave my answer like this, or there are multiple possibilities. I could give it with positive powers. So to make it a positive power, the x moves to the denominator and becomes positive, plus 12 over the x moves to the denominator and becomes positive. That's acceptable. Or if we're wanting a common denominator, the lowest common denominator would be x cubed. So we have, in order to get an x cubed for the first term, I must multiply numerator and denominator by x, giving us negative 5x plus 12. Once again, either option is okay. We can give our answer as any of these 3 options. All are completely fine. Okay, we're wanting to find the gradient of a particular function here at the point where it crosses the x-axis. So finding the gradient, we know that the gradient is the same as the derivative. When we find the derivative, that gives us the gradient function. So let's start with that. If I have my equation, as it currently is, 2 over x minus 4, we can't differentiate that. However, we can write this with our x's in the numerator. If I move the x to the numerator, the power is going to become negative. It had a positive power here. By moving to the numerator, it has a negative power. Minus 4. Now when we are differentiating this, our rule is that we multiply by the power, which gives us negative 2, and we subtract 1 from the power. So multiply by the power, 2 times negative 1 gives us negative 2, subtract 1 from the power gives us negative 2. If I differentiate this term here of negative 4, now remember when it's not written, this here has an x to the power of 0, okay? That's what's actually here when it's not written. So when I multiply it by this power, I'm essentially saying negative 4 times 0, and I subtract 1 from the power is negative 1. But anything multiplied by 0 is equal to 0. And that's why we don't have any more. This is the end, that is our derivative expression. We can say plus 0, I suppose. But we want to find the gradient, so the value of the gradient at the point where it crosses the x-axis. So I've got to find that out. I know that the x-axis occurs, that the value of y is equal to 0 at the x-axis, so I'm finding the x-intercept. So if I substitute this in, I get 2 over x minus 4 equals 0. I can add 4 to both sides. I'm wanting to solve for x, so if I was to multiply both sides by x, I would get 2 equals 4x. Divide by x times by x cancels out on the left. And then I can divide by 4. 2 divided by 4 gives me the answer of a half. So I know that this function crosses the x-axis where x equals half. To find the value of the gradient at this point, I need to substitute this value into our equation, into our derivative equation. In terms of notation, we say when x equals half, what we're going to get is that dy dx is equal to negative 2. Now remember, let's think about this. This is the same as negative 2 over x squared. So I've got negative 2 from there over a half is what I'm substituting in, a half squared. That's the same as negative 2 over a half. I square 1. 1 squared is 1 over 2 squared is 4. Another way to think about this is that we've got negative 2 divided by a quarter. Our fraction rules tell us that that's the same as saying negative 2 times 4 over 1. So we get an answer of negative 8. So therefore, the gradient at the x-intercept is negative 8. Please make sure your final answer is clear, either by writing it out again, or perhaps you could do it by putting a box around your final answer or highlighting your final answer, but some way make your final answer clear. Okay, so that's all for today's clip.